So for this problem, you're given a regular hexagon. So we know right off the bat some properties of this are that each of the side lengths are the same and each of the angles have the same measure. So you're also given two of the sides that are labeled as vector u and vector v, and your task is to label the remaining sides in terms of these two vectors, u and v. So to start off, you can see that vector u down here is a vector that's just going horizontally to the right, and it has a set magnitude. And you can see above that there's a vector that's parallel to this, that is going horizontally to the left, but it has the same magnitude. So everything is the same as u except for the direction, so we can call this vector up here negative u. Over here, for v, we have a vector that's going up and to the right, and over here we have another parallel vector, only it's facing down to the left, but again it has the same magnitude, so we can call this vector negative v. So now we're just left with these two sides. So one property of a regular hexagon is that if you draw in certain diagonals, you can actually divide it into 6 identical equilateral triangles like this. And this is helpful because since they're equilateral triangles, these side lengths, these are all the same length as vector u and vector v. So now pretty much what we're trying to do, let's say we start off with this vector. We want to find some other way to express this vector that has the same starting point over here and the same ending point here in terms of u and v. So let's say we go first along this diagonal like this, which as you can see is the same vector as negative u. And then we go up this diagonal, which as we can see is the same vector as v. So when you do that, you actually are drawing the same thing as this vector here, this mystery vector, because you're starting in the same place and you're ending in the same place. So this can be written as v minus u. So we can try the same thing down here. We have to start up here and end down here. So let's say we go along this diagonal, which is the same vector as u, and then down this diagonal, which is the same vector as negative v. And once again, you're starting in the right place, you're ending in the right place. So we can call this u minus v. And there are your answers.